Welcome to episode 2 of The Circuit. My name is Ben Bajarin, and I am here with Jay Goldberg. Say hi to everybody, Jay.
Hi, everybody. Greetings, Internet.
Greetings, Internet. Hello, world. I meant to point this out sort of last time, too. If people who are interested to follow us, there's obviously Twitter, but I know your blog, Digits to Dollars, is a good one, too. I think that's just digitstodollars.com, right?
That's right.
Yeah, I'll put those.
And
I'll
I'm
put
at
those
Jay
in
Goldberg
the.
on Twitter.
Yeah, I'll put all our information there, but I meant to mention that last time. So today we thought it would be good to talk about the verticalization of semiconductors, whether that's companies themselves building their own chips, trends within different players in the marketplace. And, it's interesting. I think this is, people understand that there is, call it a trend toward going vertical. I don't think it's fully appreciated how much strategic advantage comes into someone who can afford to do this or who has the chops to do it. But there's tons of dynamics at play around here, around the verticalization. I think everybody always uses Apple as a prime example. Apple now creates more than a dozen chips on their own, and that number is, increasing on an annual basis. They may add a couple of chips every year that they're designing. There's a host of companies collaborating with the foundries or the designers of the world. So there's collaboration with Samsung, there's collaboration with MediaTek and AMD, and those are people doing co-development from a product standpoint. But overall, maybe just go on your take on verticalization as a whole, and then we can kind of just riff on it from there.
Yeah, so I think there's an important historical context behind all of this, because you start back in the early 2000s, right? When I first got into the industry, there were 2,000 semiconductor companies in the U.S., and that was a ruinous level of competition. That there were, every socket had 7 or 8 people bidding, and gross margin pricing was terrible as a result, and so gross margins were like in the 30s or the 20s. And then we went through almost 2 decades of consolidation. We're down to 200 semiconductor companies in the U.S. plus a handful of startups, and we've seen this incredible turn in everybody's fortunes. So we've gone from 20% gross margins to 30% operating margins. Just a huge change in the economics. And most categories today, you're lucky to have one competitor, let alone 2. There's lots of monopoly and quasi-monopoly segments in the business. And that's been great if you're a shareholder or an executive at one of these companies. But it also sort of shifted the economics a little bit, right? And so suddenly the economics of building your own semiconductor made sense in a way that they hadn't since the 1970s, right? Prior to the 70s, every electronics company made their own chips, and that went away. And now the pendulum has come back. And now it's not electronics companies making their own chips. It's also the internet companies, the big data center operators who are designing their own chips, because economically it's feasible. Now, now when we can get into this, I don't think that's why they're doing it just for economics, but it certainly is something. It was this consolidation the industry has made possible in a way it wasn't 10 or 15 years ago.
Yeah, and one of the things that sort of stood out to me in both the historical context, but also sort of just understanding why we go through these phases where, to your point, you start off with a lot of companies doing one thing, and then you see consolidation. And generally that consolidation happens around standardization, and it's the standardization of something that then helps make an industry. In this case, it was the standardization of x86 that ended up then making your cloud, your data center, your client side, and now we're splitting to a couple different architectures that are viable. But it was really that standardization that drove some of that consolidation. But then the problem with consolidation or the standardization is you typically get to a spot where there's very little differentiation. And that was what we saw for the vast majority of the computing industry. Was people were just OEMs that basically bought and assembled the same number of components and tried to differentiate on design or some feature here and there. But for the most part, especially when they all ran Windows, there was very, very little differentiation. And so I think when you look at what led to the dynamics of, not that Apple was necessarily the first to do it, but they were the first to do it and really drive some scale behind a strategy for their A-series processors. But I keep coming back to Apple's sole reason for doing so leaned very, very heavily on competitive advantage and their ability to differentiate from the pack than anybody else doing their own silicon.
Right. When Apple launched the M1, there were a lot of people who said, "Oh, this is just they don't want to pay margin to Intel." And so around that time, I sat down and did the math. Right, how much does it cost to build, to buy silicon from Intel versus building it yourself? And building your own silicon is not cheap, right? You have to have a team. Yeah. It's heavy fixed cost. You have to have a team, which is hundreds of millions of dollars, $1 billion team probably at Apple. You have to have, you have to have your foundry relationships and all the costs associated with that. And then you have to have the inventory and the processes and the operation, all that stuff. And if you actually run the math that way, M1 is at best a break-even proposition. And I think this is true for all of these homegrown silicon solutions, from whether it's Apple or Google or Amazon or any of them. They're not doing it to save a few bucks that they would otherwise go to Intel's profits. They're only doing it when it conveys some form of strategic advantage.
Yeah.
Right. And in the case of Apple, it's very clear. Like the A series and the M series chips make the iPhone and the Mac better, like in ways that consumers can appreciate. It's better battery life. It's crisper graphics. It's smoother look and feel in the UX on the iPhone. Like that's really tangible to consumers. People are more likely to buy an iPhone, and that leads to billions of dollars in additional revenue. And so when you look at it on that scale, it makes tons of sense to invest $1 billion in doing your own silicon.
Yeah.
And I think that's the important thing. Like people sometimes forget that it has to have you have to have some strategic advantage here.
Right. Yeah. And the economics point, I mean, you're exactly right. I mean, there's a range of numbers out there on Apple's costs. And while it may have for a short time, I don't think this is true anymore, where it may have for a short time been somewhat less expensive cost per chip at TSMC, the overall costs that were baked into that from, it costs hundreds of millions of dollars to make a new chip. Like every generation, they're spending hundreds of millions of dollars on something new in development costs. And so it's not trivial, which is why, my initial point, not everybody can do this, but everybody has some desire to do it because they feel how much more competitive it is at a product level, whether that's your cloud data center, whether that's going to be your cars in the future, your computers, your phones, any number of things that have a decent ASP, it's going to become an increasingly competitive field. And that's where I think it'll be just really interesting to see, one, how the semiconductor companies navigate that. Because if you talk to like a Broadcom or Marvell, or even, AMD, it's a small percent, right? 10%, maybe 15%, give or take per quarter. That is semi-custom from them. The vast majority, it's just merchant silicon. But will that number grow? I mean, I think that's an interesting debate as more companies come to them and say, we need to differentiate, or how can we roll something of our own because the competitive field is getting so strong.
Yeah, and I think to me, there's so much going on. One is there is this function of Moore's law slowing, right? Moore's law is slowing. And a generation ago, you could have said, well, I need a new compute solution to do these special things. If you waited 18 months, there'd be a new CPU out.
Yeah.
Now it takes 5 years or whatever to get to get to the next node. And as a result, everyone's scrambling to find some other source of compute and performance improvement. And custom, semi-custom is one really good path to do that. But I think there's another aspect of this that isn't totally understood, is we're seeing the introduction of like whole new categories of chips, right? When we start talking about ASICs, like special purpose built chips to do one thing, there's lots of special tasks out there that nobody really considered before, right? And my favorite is the VCU from Google. Like I'm obsessed with this chip, right? Google invented the VCU, right? The video encode decode unit, to do compression for YouTube videos, basically. And it was just a category that just didn't exist before. Nobody was doing this, right? They just did it on CPU before, right? And by doing this, they haven't actually broken out a lot of numbers about it, but they've said some things where it's 50% better performance versus CPU. It leads to a 30% improvement in performance, like, or 30% reduction in storage, right? And so you imagine your YouTube, the biggest repository of video in the planet, and your storage bill goes down by 30%. I mean, that's got to be billions of dollars in savings. Plus your transit costs, your networking costs go down by the same amount too. And that's another few $billion in savings. And to me, though, the most fascinating part of of the VCU is the fact that it was actually designed by YouTube engineers, right? These were people whose day job is to run YouTube and write the software that, recommends videos and does playback and inserts ads. Like, that's their day job. And on the side, they just designed a new chip. And to me, that's just super fascinating. It speaks to, I don't like to call it the democratization of semiconductors, but there is this element of, you sort of remove it. You're disintermediating the silicon people, right? You don't need a special purpose semi engineer to design the chip. You'll need them to get it to production. Right. But in terms of actually doing the circuit layout, you have a well-trained software engineer. That person can actually now design a chip. And Google's actually built the tools to make that possible. And so I think that's really fascinating. I have to think that ultimately Google's going to open source some of those tools, and we'll see more of that.
Yeah, I think you're
and they're not stopping.
Absolutely...
Like they probably have I'm just saying they probably have another dozen chips in design.
For sure.
So
and I think you're exactly right, which is why I think one of the more interesting parts of this discussion is one, to understand the foundational layer for why this happens, right? People either trying to save costs, they might want to save energy in the data center, and so they create some kind of an accelerator or something that emphasizes low power or offloads a workload from something that's intense like a CPU or a GPU. Whatever the reasons that they want to do it, you're absolutely right that it makes it so much easier because you don't have to hire large, engineering teams. You could go to the foundry, or you could go to AMD, right? MediaTek, Qualcomm, maybe you could go to Broadcom, and they can help you as long as it's something that's in their sweet spot. And so you're really not starting from scratch, but it's also by nature of assuming that, part of this is ARM. And I know, at some point we'll probably do a whole segment on architectures, but yes, you've got RISC-V, but ARM also makes it fairly easy if that's the platform for companies to come on and use some of that generic IP, build upon it, and customize what they want. And the other thing I think is really interesting on that too is just what's going on in the world of FPGAs. As they become higher compute capable, they're basically blank slates. People can just use them for whatever they want, right? Could be security, could be AI, it could be low power. It's the world is up to them in terms of how they want to now differentiate with custom silicon.
That's right. And I think what's fascinating to me is how the big semiconductor companies are responding to this, right? Because on some metrics, this is them now competing with some of their biggest customers.
Exactly.
And for the most part, rather than fight it and lose, most of them have chosen to embrace it because they recognize that the big internet companies in particular, they don't want to do all of it. They just want to do the sort of glamorous software facing pieces that really are important to their strategic advantage. They don't want to do the SerDes and the IP and the IO and all that stuff, all the sort of like little side bits, let alone, working with the foundries and getting integrated fully into all the PDKs. And so you see some of the big chip companies are providing sort of, semiconductor operations as a service, semi-custom silicon as a service to these companies. And it's a smart strategy because they know that they can sell the service, which is not a business they want to be in, but they can sell that alongside a bundle of other products, networking products. Like Broadcom alone this is already a $2 billion a year business for Broadcom. Yeah. Right. Yeah. Broadcom is really the one who helped out get the A series and the M series into production. Yep. And Marvell's doing it as well. They've talked about they've talked about it a lot. AMD as well at their analyst day talked about it a lot. And AMD is interesting too because they have an FPGA asset now with Xilinx. And so that's a pretty powerful combination where they can go to any of these big customers and say, do you want a off the shelf CPU, or you want your semi-custom stuff? We can help you with that, and we'll throw in FPGAs. We'll help you build the right mix. And I think that's the smart approach. And not to bash Intel, but I think that's part of the challenges Intel is going to face. Is, like, they can't necessarily build that business right now because they're a little distracted by fighting to survive.
That's a whole different conversation on Intel's challenges, ones that we've had for many years. But no, I think you're exactly right. And one of the things that I think is interesting, if you just look at least the way I philosophically think about the way Apple designs chips, and so I'll lay my theory on you, and then how this might apply to other companies. And I want your take on that. So the main one being, Apple's very tactful on what they design silicon for when they feel like that's a part of the core experience. So things like display drivers, obviously CPU, GPU, we all believe they'll make a modem at some point, recognizing how difficult that will be and the surrounding RF, but that is a critical part of the device experience. They'll try. It's a critical part of the device experience. But whatever it is, it's something that they have deemed, if we make this, the experience will be better than if we buy something else. And to some degree, I feel like that skews more toward components from the supply chain that are not commoditized. So essentially my theory is, to your point about YouTube, right? Just name your company, whatever their strategic advantage is or where they want to double down to have some advantage. If it's a commodity chip, if it's a microcontroller, something simple, you probably don't need to design that. But if it's something that for you has a core advantage to whatever your service is or your product, then it makes more sense. And typically those are going to be higher ASP parts. Now, you can weigh in on that in a second, but then the implications of that goes back to your point about how do semiconductor companies respond if their higher margin chips are being designed either by them or by other people. I tend to think you'll see a lot more semi-custom than anybody's forecasting now, because if you talk to Broadcom and Marvell, they're saying like 20-25% at max. I think it could go more than that for at least the bigger companies who have the chops to do it or the economics to do it. But my point is, it's not commodity. It's something that's a higher margin or a higher ASP product in that stack that someone may want to design because of how important they feel it is to their experience.
So I agree with that philosophically and intellectually. I think that's right. After all, I think there's only a limited number of companies who can really afford to do this. That being said, every time I look around, there seems to be somebody else getting in the mix, right? John Deere. Right? John Deere makes tractors and agricultural heavy equipment, right? Not seen as somebody who is very electronically forward looking, but really is, right? They're at CES every year. We're going to go see them. And they're designing their own chip, right? Because they want to have autonomous tractors. There's a Wi-Fi company, TP-Link, which is a Taiwanese Wi-Fi access point maker. They're building a Wi-Fi chip, right? Or they built one. And it's like, I wouldn't have thought the world needed one of those. They can get their plenty of good off-the-shelf solutions, but TP-Link does probably 60-70% of their business is Wi-Fi, and they felt it was important to try. And so I think what we're going to see is a lot of people jump in the mix. Long term, how many keep with it is, again, it's a finite number. It's 1-200. Yeah. But there are going to be some surprising names.
Yeah. Well, and that's why I think this discussion of how much specialization starts to come into a product roadmap or a product portfolio. And you're absolutely right. I mean, it skews a larger company generally, right? A startup's probably not going to do this from scratch if they're a software company. It does require some size and then obviously the chops and money to do so. But I do feel like, right, that part of the premise was, and I remember number of conversations with NVIDIA and Jensen around this, where, he actually had a very similar fundamental premise, which is that the GPU as a general purpose compute unit can do all these things, not just graphics, right? So the point of CUDA was take any of your high workloads and run them on GPUs. And so the point was to say that, like, if you've got something that's general purpose and you can write the software to do it. You could have it do whatever you want, right? So it's really the software, hence, it's the platform that NVIDIA provides. Similarly, I think there's approach to those for a whole range of other, whether they're ASICs or whether they're specialized NPUs or whatever, where when you have something that has a specific purpose, whether that's AI, security, low battery, efficiency, you name the number of things, but it could be customizable for the needs. It makes this platform approach to silicon a lot more interesting. And again, it's more software than it is design. But I'm curious how that evolves, because I think it's attractive. And then again, right, the point is, well, maybe a Marvell and a Broadcom or AMD, maybe Intel, right, become more of a software platform company where a lot of their economics comes from services, not just the end chips themselves.
See, that's tricky to me, because I don't think this is a great business for a lot of these semi companies, right? Doing the semi-custom stuff it's non-recurring, which is the big problem, right?
Right.
The economics of it are not fantastic. It's pretty high cost and pretty low margin. So I don't think we go down too far down that path. I'm also more skeptical than you are about semiconductor companies getting into the software business, especially large established semiconductor companies. But I do think they're going to have to, at the very least, radically rethink how they do sales, how they approach their customers, how they build long-term relationships with these big customers. And I think that the days of sort of just handing things over, taking orders and handing it over to your customers are gone.
Yeah.
You need a lot more software engineers. Like I know most semiconductor companies today have more software engineers than hardware engineers.
Yeah, exactly.
Right? Because they need to get all that software to work on the chips. And so I don't know if that's necessarily I don't think that becomes a new business for them, but I think it's going to continue to alter the way that they do business.
Yeah, no, I totally agree. But your point about sales is a great one. But retrospectively, this is where I always think these things are interesting. We talk to a lot of sales teams from a lot of companies in the industry, but just going back to, my startup days where I ran product for a web services company, and our sales team would be out there talking to our target demographic, and they'd come back and be like, hey, I just sold this, but you got to build these features for me. And I was like, what do you mean we got to build these features for you? Like, that's what the customer wants. They want, and I'm like, not everybody's asking for these features, but I needed it to close the deal. So I promised we'd build these things. So you go build me, said services. So part of that, right, in that chain is, well, you got to keep your customers happy. You also want to keep them loyal, right? You don't want to lose them. So part of this is where I just I just think, out loud, when you have a software stack, you might be saying, okay, well, look, we've got the capabilities to do this. So not to say that they'll overextend their sales, but I could see a lot of that conversation drive to, we'll have more loyal customers when we can add parts of this, whether that's a software stack or even if the customization is aiding in software, right? I just wonder how much that will fuel their need to not lose customers.
I think that's how we got into this problem or this position to begin with.
Yeah, that's true.
Right? I think the really big change about why companies are rolling their own silicon, it's not about the economics or strategy or anything. It's the fact that doing your own silicon allows you to control the roadmap.
Yeah.
Right. I think that's what's really at stake here. When there were 30 competitors and you could pick and choose whoever you wanted, you could strong arm one of those competitors into building you what was effectively a custom chip.
Right.
You could control your vendor's roadmap. That is not possible when there's only two vendors or one vendor. And so designing your own silicon is a way to recapture that initiative and to control the roadmap. Right. And like I always think about Apple in this, because Apple is really good at this, even for parts that they're not designing themselves. Like you go to all the small passive component vendors out there, all Apple vendors have to go through this crazy process of constant technical reviews and constant audits and constant scrutiny that effectively pushes the roadmap of those vendors to do exactly what Apple wants.
Yep.
Because Apple is there and has the technical chops to sort of drive that process. And I think that's just part of. I think that's what really is matters in all of this.
Yeah, well, and Apple has the benefit of also funding in advance those efforts, so the company is essentially getting guaranteed income, which not most companies can do. But architecturally, there's so much now coming into this where you again, if your costs have come down, like you said, and you don't need to hire silicon engineering teams, because again, right, anybody that's a good silicon designer is not sitting on the couch somewhere. They're employed. And so if you have these ambitions, where are you going to get these people? Like that's not a trivial problem to solve. You go to someone who has them, which is again where I think the semi-custom parts come into play. So the other part of this I think is interesting is how verticalization might become more of a nationalistic strategy. I know, the military does do some design chip wise, but the extent of that, right? We can theorize. China is obviously trying to get more into chips for the sole purpose of doing more of their own, but that's also their product companies, not necessarily how their government will use it. So I'm curious on your take on how much does all of the same fundamentals that we talked about, from competitive advantage, the costs and efficiencies coming down to make these things possible, how much does that maybe come to a national standpoint, just from the standpoint of nations competing or wanting to hold on to that competition for their own strategic advantage as well?
So there's a bunch of layers to that. I would say first and foremost, I mentioned before, part of the genesis of roll your own silicon is it's a coping mechanism for the slowing of Moore's law. Mm. And if you think about it, China now has a very big problem with Moore's law. They're basically cut off from it. And so I think they're going to have to use all the strategies they can to eke out performance gains, especially when they're dealing with 14 nanometer, 16 nanometer chips. And so they're absolutely going to have to adopt a lot of these customized roll your own solutions, because that's going to be one more way that they get performance gains if they can't get advanced processes.
Right.
And I think I haven't mentioned it, but I have this list of companies that are doing vertically integrated silicon, right? And it's about 40 names on it. And half those companies are Chinese, right? And it comes in sort of two flavors. One is the internet companies, Baidu, Alibaba, Tencent, are all doing a bunch of silicon on their own, much as Google, Facebook, Amazon are doing. But there's the other half of that list is automotive companies. Right? There is a huge amount of investment going on in automotive semis in China.
Yeah.
Right. And in fact, China has always done a lot of investing in semis, but a lot of that's slowed this year for domestic politics reasons. We can talk about some other episode. But the one area that it continues to see a massive inflow of venture funding and government funding is semis for autos. And a small portion of that is microcontrollers, but most of it is around ADAS, digital cockpits, and autonomy. Right. And I think what's going to happen there is the Chinese auto companies are all looking to build their own silicon solutions, right? For everything, for ADAS, for autonomy. They're either directly doing it themselves and have teams internally, or they've heavily invested in startups that will do it for them, with the presumption that those startups will eventually get folded into the parent. And I think auto is one of those really important areas for exploring the limits of the latest U.S. sanctions on China. If the U.S. government really wants to, they can shut down not just China's chip industry, but also China's auto industry, which is a big deal, right? And I think the way it stands now, it looks very likely that Chinese auto companies are going to be shut off from autonomy.
Yeah.
Now, I don't know how long it's going to take to get to autonomy. But you're going to need advanced chips to do that, and that's going to be really hard for Chinese companies. But that hasn't happened yet. They're they're still preparing for the future, and they're all absolutely building their own silicon.
Yeah, that's interesting. I mean, I think part of this too is, again, like how much do the corporate institutions themselves, right, feel like they need to do this for, right, the data center for the government, which again, I don't have any idea how much of that is custom. I would assume maybe a small, but clearly they're using a bunch of market chips from others. Obviously the military does that for, a lot of the weaponry and jets and tanks and whatnot. But I mean, that's not necessarily part of, or maybe it is, you tell me, part of the thinking from the whole CHIPS Act. Is it similar in light to the way that China thinks about that, about how, well, if we invest in this, yet we will keep a portion of that proprietary, because that's part of our ambition, part of the IP and even the R&D, that it doesn't just fuel the global economy, but there's parts of that that they can not sanction off, but keep off from other people for American innovation, which again could come back to autos, right? Any number of product companies that they might want to isolate and give only those chips to.
So I recently did a project for a client that is not so recently, actually, it was a few years ago. I did a project for a company making AI accelerators, and we were just doing a competitive landscape analysis. And there ended up being, we found dozens of companies in the US doing this, but there were 100 plus in China working on it as well. And most of them seemed pretty junky, but there were two or three that were, most people told us were the most promising, performative chip designers out there. And when we reached out to them, we found they wouldn't respond to us. They wouldn't talk to foreigners. And ultimately, it turned out that all of them were somehow affiliated with the People's Liberation Army. Not so much directly, but like they just knew that was their biggest customer, and they had nothing to gain by talking to foreigners. And so, I think a lot of those companies have been outpaced in terms of performance. But certainly, there was already then a very perceptible sense of we don't want to talk to foreigners. We don't want their business. We're just going to keep this at home. And I don't think we see that in the U.S. We don't see that dynamic exactly. I mean, most U.S. chip companies really would like to sell whatever they can to China. But I do know that in the CHIPS Act there are a number of the sort of the big U.S. Defense companies have semi projects. Some of they already they've been designing their own chips for years, and I know they're all lobbying for their share of the CHIPS Act funds as well, because they're like they say, hey, we've been doing this here, domestic U.S. chip manufacturer for years, help us out, and it's it's a fair argument, and I have to think that that's all going to start expanding.
Yeah, no, I totally agree. So one last question to end on, right? So as far as we know, I mean, I think as far as anybody knows, Apple is the most vertically integrated when it comes to silicon. If there was an industry that Apple's maybe not going to get into, you could say data center, arguably automotive. Is there any other segment where you could see somebody going as vertical as Apple?
I think cars. I think the automotive sector is going to head that way. Just because to do anything digital in the car, and certainly for autonomy, you could make a pretty serious argument that the companies that make autonomous vehicles are going to be radically different than the companies that make cars today, and that kind of disruption lends itself to a pretty high degree of vertical integration. I will say though, I actually think of it slightly differently. I think of it as Apple is by far I actually say Apple is the best run semiconductor company on the planet, and they don't sell semiconductors. But at the same time, I think Google is the most innovative semiconductor company on the planet. Like the things that they're coming up with are super, super fascinating.
Well, maybe we'll hit that on a whole topic, a whole podcast topic on its own, and innovative and executionary. But I agree with you on Apple, and Google's an interesting one, and I'm sure there's more to come. So with that, we'll wrap it up. Thanks for listening, everybody, and until next time.